Welcome to Mission Apsc AJ YouTube channel. আজি আপোনালোকৰ মাজত ডিসকাস কৰিব লৈছো আৰ্ট প্ৰেছাৰ theory. This chapter is from geotechnical engineering background, and this chapter has 3 to 4 marks weightage in APSC AJ exam. That's why today we'll try to finish our art pressure theory subjects or art pressure theory topics. So here we have to learn what do we mean by the active and passive art phases, then various formulas, because artificial theory related বহুখিনি numericals এক্সামত সোধা যায় আৰু কেতিয়াবা ইয়াৰ থিয়ৰিৰ ওপৰত বেচিছ কৰিও MCQ আহি যায়। চ' সেইকাৰণে আপোনালোকৰ কাৰণে আজিৰ এই ছাবজেক্ট এই চেপ্টাৰটোত আমি আপোনালোকৰ কাৰণে লৈ আহিছোঁ আৰ্ট ফিচাৰৰ ওপৰত ডিটেইলছ। চ' আপোনালোকে যদি ভিডিঅ'টো চাই উপকৃত হৈছে বুলি ভাবে বা লাইভ ক্লাছটো কৰি পেলাই উপকৃত হৈছে বুলি ভাবে দেন প্লিজ চেনেলটো ছাবস্ক্ৰাইব কৰি দিব আৰু কাষত থকা বেল আইকনটো প্ৰেছ কৰিব। আৰু যদি ভিডিঅ'টো ভাল লাগে দেন লাইক কৰি দিব so that I can upload more numbers of videos. So এইটো জিঅ'টেকনিকেল ইঞ্জিনিয়াৰিঙৰ এটা টপিকছ হয়, that is art pressure theory. So art pressure theory, we have mainly two art phases. One is active, another is passive art pressure. So we have to know how we can differentiate between the active and passive art phases. Okay, let's suppose we have some retaining walls. Suppose this is a retaining wall. I'm doing one roughly a retaining wall. Okay, so in this retaining wall, if suppose this particular wall is moving towards the backfill, if it is moving away towards the backfill, if the retaining wall try to turn this way, then it is known as active art pressure. If because of the soil present in that particular retaining wall, if the wall try to move towards the retaining wall, or it's try to move towards the backfill, then you can say that it is passive art pressure. We'll try to discuss about these two type of phases, and also we can discuss about the art pressure as rest. Art pressure is at rest means the pressure which is exerted in horizontally. Okay, so in case of active art pressure, if the wall moves away from the backfill, a portion of the soil behind the backfill will also try to move along with the wall. So ইয়াতে কি হৈছে, যিখিনি আমাৰ soil আছিল, that soils will try to move along with the wall. Okay, যেতিয়া active art pressure হয় বা active stageত pressure exert হয়, at that time a portion of the soil which is basically the behind the backfill or behind the থকা যিবিলাক soils হয়, they will try to move along with the wall. The portion of the backfill which move along with the wall is known as failure weights. So যিটো portion along with wallৰ লগত move কৰে, that is nothing but failure weights. The resistance of soil due to its shear strength is developed at upward and outward direction on the rupture surface, hence pressure on the wall decreases. So যেতিয়া in case of active pressure, the resistance between the soil loosen the shear strength, or the shear strength is developed in upward direction. That's why the pressure on the wall try to decrease. Okay, so the decrease in pressure takes place up to an extent when the entire shear resistance of the soil is mobilized. So there is a decrement of shear strength. That's why the soil fail. The minimum pressure acting on the wall at this stage is termed as active pressure. So to maintain the stability of that retaining wall, the pressure which is required is known as active pressure. For active stage, strain required is in order of 0.2 to 0.5%, or 0.2 for dense sand and 0.5% for loose sand. This is important. So sometimes in exam they ask for active stage how much strain is required to maintain the stability of that retaining wall. So you have to know that this is a 0.2% to 0.5%, where 0.2% is for dense sand and 0.5% for loose sand. So let's have a look of retaining walls in case of active art fissure. So here in this figure you can say this is the retaining wall. This particular wall is the retaining wall. Okay, this is straight line, or this wall is a retaining wall, right? So what happened under the influence of this soil? The retaining wall try to move away like that. Okay, the retaining wall try to move away like that because of the influence of the soil which is present along this wall, right? So here failure waves is developed up to a certain point. This failure wave is occurs at an angle 45 degree plus 5 by 2. You have to remember this. So always in case of active stage, the failure wedges which is formed is basically max angles with horizontal 45 plus 5 by 2, where phi is the angle of internal frictions of that particular soil. So ইয়াতে কি হৈছে ৱালখনৰ লগত this particular wall, the soil's particles behave as a weights. Some soil particles they behave as weights, and the shear strength of that particular weights becomes zero, and these have a tendency to fail along with the wall, right? So the plan which is developed is known as rupture plan, and the resistance which offered by the particles is the shear resistance. Okay, this shear resistance will try to resist the downward moment, right? In the opposite phenomena happen in case of passive art fissure. So passive art fissure ক্ষেত্ৰত opposite phenomena uh, হয়. In this case the wall moves towards the backfill. আগৰটোত কি হৈছিলে? In case of active phase the wall moves away from the backfill. This is a backfill, the walls goes away from the backfill, right? But in the second case the wall moves towards the backfill, the wall is goes like that. Okay, so we'll see the figure here. You can see that this is the original vertical walls. The wall try to deflect up to Dallas, and because of that also rupture plan is developed. Then shear resistance is also developed. The angle in this case, the failure wedge angle, you have to remember that is 45 degree minus 5 by 2. 45 degree minus 5 by 2. These two things we have to remember. First thing is that in case of active stage, the failure wedge form at an angle 45 degree plus 5 by 2. In the second case, the failure wedge from at an angle 45 degree minus 5 by 2 in case of passive. And here strain amount is also different. You have to remember that strain amount also. In this case, if the wall moves towards the backfill, the shearing resistance of the soil builds up against the wall, which results in increase of pressure on the wall. This increase of pressure takes place up to an extent when the entire shear resistance of the soil is mobilized. Okay. The maximum pressure acting on the wall is termed as passive earth pressure, and passive stage the strain is required. You have to remember in the active stage the strain is required 0.2 to 0.5%, but in case of passive stage the strain is more, and it is 2% for the dense and 5% for the loose sand. Okay. So if the portion of the soil try to move along with the wall, then that portion is known as failure wedge. The portion similar manner in case of active stage also, the portion which is try to move along with the wall, that is known as basically the failure wedge. Okay, failure wedge, and the failure wedge angle is 45 degree minus 5 by 2 in case of passive, and in case of active 45 degree plus 5 by 2. Okay, so we'll try to derive some relations now so that we can understand how the effective stress or the cohesions have importance in the active and passive pressure stage. So we'll look into the stress relationship between the soils. Here this expression is sigma 1. Sigma 1 is nothing but it is the normal stress. Sigma 3 is the basically the minor stress, and sigma 1 is the major stress. From the more Coulomb failure, we'll get this expression once if you study the more Coulomb failure, then after more, in that particular chapter you will get one relationship between the minor stress and major stress, is that sigma 1 is equal to, that is major stress or the normal stress, is equal to sigma 3 10 square 45 degree plus 5 by 2 plus 2c 10 45 degree plus 5 by 2, where phi is nothing but phi is basically angle of internal frictions or angle of internal friction, or internal angle, you can say angle of internal friction, and sigma t is basically the minor stress, and c is basically the cohesions, right? But for cohesionless soil, if we look at the soil which is cohesionless, soil or sigma value is 0, then the term remaining as sigma t is nothing but 10 square 45 degree plus 5 by 2. Okay. So if you consider the active stage, in case of active stage, sigma 1 becomes sigma verticals, okay, and sigma 3 becomes sigma a's, okay. That means horizontal pressure, that is this sigma a's is nothing but minor, and the sigma 3 is nothing but the major, right? So we are substituting sigma 1 as sigma v, that is vertical stress, and sigma 3 is equal to sigma a's, this is the horizontal stress. From that, I can get that sigma v by a is equal to 10 square 45 plus 5 by 2. So sigma is by sigma v is equal to 1 by 10 square 45 degree plus 5 by 2. And we know that 1 by 10 theta is nothing but cot theta. That's why we can write as sigma h by sigma v as cot square 45 degree plus 5 by 2. And this the ratio between the sigma h, that is horizontal stress, with respect to the vertical or normal stress, is known as coefficient of active art feature, and it is denoted as Ka, and the value of Ka is always less than 1. The reason behind is the sigma horizontal is a minor stress, that's why the value is less as compared to sigma v. Sigma v is the major stress, that's why Ka value is always less than 1. Okay. So Ka is cot square 45 degree plus 5 by 2. In case of cot square 45 degree 5 by 2, if you simplify it using trigonometry, then you can get as 1 minus sine phi 1 plus sine phi. This is an important formula. Many times APSC gives some internal angles like the phi values, and they ask us to calculate the value of coefficient of active art feature. Then we'll simply using the formula 1 minus sine phi 1 plus sine phi, right? So it is the simple formula. In on the basis of this formula, sometimes they are giving the phi value and ask to find Ka. Sometimes they are giving the Ka values and ask to find phi, that is angle of internal frictions in case of active earth pressures. And always remember, the active earth pressure, the Ka value is always less than 1. Okay. So, and what will be the active art phasors? So active art phasor is basically we have to multiply Ka with sigma V, that is the major principal stress. So what is the ultimate formula for active art phasor? This is the formula for coefficient of active art phasor, and the active art phasor in a certain point we can given as PA is basically the coefficients of art pressure into the vertical stress sigma V. Then similarly we can derive for passive stress. So how to derive for passive stress we can discuss now. So in case of passive stress we can here the reverse thing is happens. Okay, here in case of active stage the measure is sigma 1. In case of active the measure is nothing but the vertical stage. But here, in case of passive, since the wall is moved towards, that's why the horizontal force is more as compared to vertical force. That's why horizontal force is basically sigma 1. Okay, that is major stress is sigma h, and minor stress is sigma v. Try to remember this. In case of active art feature, the major stress is vertical stress, and the minor stress is the horizontal stress, right? So here we can substitute again from the equations one for more column failure, and here the major stress is sigma s, the minor stress is sigma v, and then if you find the ratio between sigma s by sigma v, we can get 10 square 45 degree plus 5 by 2, that is kp. And you have to remember from trigonometry we can know that the 10 square 45 degree plus 5 by 2 we can write as 1 plus sine phi. It is opposite to the uh, active earth phasor. 1 plus sine phi divided by 1 minus sine phi, right? 1 plus sine phi divided by 1 minus sine phi. In case of active earth phasor, the value is 1 minus sine phi divided by 1 plus sine phi. But in case of passive, just interchange the signs. So here in the upward term there is a positive sign, and in the downward side term there is negative sign, right? So in case of passive art phasor, the value of kp is always greater than 1. Why the kp value is greater than 1? Because in here, in this case, the horizontal force is more. Horizontal force is more, that's why the wall moves towards the wall, and the ratio between sigma h by sigma v is given as kp. And sigma h, since sigma h is more, suppose sigma h is 5 and sigma v is less, suppose 3, obviously the ratio will be more than 1. That's why sometimes in apsc exam they're asked to ask some kind of questions like which one is more, whether active artificial coefficient is more or passive art phasor coefficient is more for same angle of internal frictions, then the answer will be passive art phasor, because passive art phasor cases sigma h value is more, and the ratio between sigma h and sigma v is basically more than 1. But in case of active stage, the ratio between sigma h and sigma v is less than 1. And these two are contemporary. We can say that ka is nothing but 1 by kp. So if you get the kp value is 3, then ka value will be 1 by 3, just reciprocal, right? So we have one relationship. You can remember that relationship, that is ka, that is coefficient of art fissure at active stage into coefficient of art fissure as passive stage equal to 1. And we can also find the passive art fissure, that is nothing but the multiplications of kp, that is coefficient of passive coefficient of art fissure into the vertical stage sigma v. So we have two formula, one is PA, that is active art fissure, and another is passive art fissure. Here the sense is only occurs the coefficient. Here the coefficient says Kp, and in other case the active stage the coefficient of fissure is Ka. Okay. So here we can have a look of the diagrams. Okay, what is the diagram for active phasors, or what is the passive art phasor? In case of active art phasor, if you draw a diagram, then you can get one rectangle, one triangle. In the base you can get the value as ka ace, right? Ka gamma ace, where ka is nothing but coefficient of art pressure at active stage, gamma is the unit weight of the soil, and h is basically the height of the backfill or height of the retaining wall, right? So in case of passive art pressure also, the distribution is triangular and it is linearly increasing, and the value will be at the base kp gamma into h, where kp is nothing but coefficient of art fissure at the base level in passive stage, right? So active and passive art fissure for cohesive soil. If the soil is cohesive, in the other case we are discussing the soil is cohesionless. That's why we are putting the value of C equal to 0 in that particular equation. Let's see the equation here. This is the more column failure envelope, right? So this is the formula, and from we are determining the formula as 1 minus sine phi 1 plus sine phi. This particular formula is derived from that particular Mohr Coulomb failure relationship, but here we are assuming C equal to 0, that is because of cohesionless soil, like for sand or for gravel. But in the second case we are considering cohesive soil, that is for clay. That's why we are considering C term also in the second case. Let's try to derive the expression for cohesion soil, or the soil which are having cohesion like clay, silt, etc. So here C is not equal to 0. For Mohr Coulomb failure relationship, we are getting sigma 1 is equal to sigma 3, 10 is square 45 plus 5 by 2 plus 2C 10 45 plus 5 by 2, right? So active stress always, the major stress is vertical stress, since the wall is moved outward or wall is moved outward directions, right? That's why the vertical stress is more as compared to horizontal stress. So the major stress sigma 1, the sigma 1 will be sigma vertical, and the minor stress will be sigma horizontal. But in the same way, if we determine in case of passive earth pressure, uh, the direction is opposite. In that case, the measure will be sigma horizontal because the wall is moved towards the backfill, and sigma t will be sigma vertical, that is minor is sigma vertical in case of passive, right? So just substitute for active case sigma 1 as a sigma v. We are substituting sigma 1 as a sigma v, sigma t as a sigma ace. Okay, so then we are trying to determine here the change occurs this term c. Okay, in the previous case we doesn't have the cohesion value, but here we have the cohesion value, right? So sigma v cot square 45 degree plus 5 by 2 sigma h plus 2c cot 45 plus 5 by 3. That means we are dividing with respect to cot 45 cot square 45 degree plus 5 by 2. So after that, finally we'll get one expression sigma h is equal to sigma v cot square 45 degree 5 by 2 minus 2c cot 45 degree plus 5 by 2, and we know that cot square 45 degree is ka. So here we can write sigma v into ka. Sigma v is basically ka into sigma v, and here we can write 2c, since cot square 45 degree plus 5 by 2 is root over k, so we can write as root over k. So the final formula for cohesive soil in case of passive earth pressure coefficient, uh, sigma horizontal, the horizontal force will be ka sigma v minus 2c root over ka, where k is the active earth pressure coefficient and c is the value of cohesion. Sigma v is basically the vertical stress, right? So next we'll go for we'll try to determine the passive stress formula. In case of passive stress formula, uh, in case of passive stress formula, we can say that sigma 1 here, the sigma 1 is nothing but sigma horizontal, since horizontal pressure is measured, and we have sigma t is equal to sigma v, since vertical pressure is minor, right? So we can from that we can say that sigma h is equal to sigma v 10 square 45 plus 5 by 2 from the Mohr Coulomb failure envelope 2c 10 45 degree 5 by 2 is equal to pressure p. So here the change occurred in case of cohesive soil, the passive earth pressure is this. So mainly we're getting some important formula in case of cohesive soil. The active earth pressure pa is basically you can write as pa is basically we can write as sigma kp into sigma v, kp into sigma v plus 2c root over kp, right? Kp into sigma v plus 2c root over kp in case of passive earth pressure, right? And in case of active earth pressure, we can write as kp into sigma v minus 2c root kp, right? So we have to remember these two expressions for cohesive soil, right? So for cohesive soil, we can remember these two expression. Then we'll go for the next part of the derivations. So another important term we have to remember in case of active and passive earth pressure, that is basically the unsupported cut. This is important. What they mean by the unsupported cut, right? So in case of unsupported cut means in case of cohesive soil, you uh, active earth pressure, you can see that the active earth pressure is Ka sigma V minus 2C root over K. Suppose the active earth pressure is 0, that means sigma H is 0, then we can get Ka sigma V is equal to 2C root Ka. So in this condition, although the active pressure is not there, although there will be some stability of the structure, right? So or the some stability of the soil itself, because we have one negative parameter, that is 2C root Kp. Because of this, after overcoming minus 2C root Kp, the soil experience the active pressure, right? That's why twice of Zc, if you consider that particular stress as twice of Zc, we can say that the twice of Zc is nothing but the excavation without any lateral support or the unsupported depth. Since this negative term, first the soil have to overcome this negative force. After that, since this is negative, we have to overcome plus 2C root Kp force. After overcoming this, the value which is observed, that is twice of Zc is 4C gamma Ka. We have to remember this formula. This is nothing but tension cake or depth of the unsupported land, and tension cake is 2C gamma root K. Tension cake is the force where the effective stress sigma H is 0. When sigma H is 0, when the value is 2C gamma root over Ka. Okay, 2C gamma root over Ka. Always sometimes the people confuse what is the lateral support or what is the tension cake. Tension cake is 2C gamma root over K. Tension cake is the point where the effective stress is 0 or where the sigma H is 0, and the unsupported excavation land is 4C, twice of that particular tension cracks value. That is 4C gamma root over Ka, and it is basically the depth up to which the soil is stabilized. That means when the soil first overcome minus 2C root over Kp value, after that the positive amount of plus 2C root Kp, that means twice of Zc, the soil always able to retain its unsupported. Suppose we are digging the soil. Suppose we are digging the cohesive soil up to the depth of 2 Zc. That means up to the 2 Zc, the surrounding soil will not come to the this digging hole, right? That means they have own stability up to the length of 2 Zc. So that is known as basically the lateral support. Lateral support means soil is able to stay up to the point, that is up to 2 Zc without any support. Okay, so it can, and this is the twice of the tension cake, and tension cake is the point where the effective stress sigma H is equal to 0. So tension cake is 2C gamma root over Ka. You have to remember it, and you have also remember the value of this one lateral unsupported cut is twice of Zc. Okay. Then we have then we'll go for the seed pile walls in the next seed pile wall in the next part. Seed pile walls or seed piles are basically the piles which are generally provided at the bank of gravity dam. Suppose we have one gravity dam. Okay, we required gravity dam. Suppose in gravity dam we have some piping failure. Okay, suppose আমাৰ কিবা piping failure হৈ আছে. Piping failure means suppose since it is the upstream, এইটো আমাৰ upstream হয়, and this is downstream, right? So piping failure এনেকুৱা এটা condition হয়, the soil below the gravity dam, this will act as hollow pipe or hollow water pipe because of the seepage phenomena. So ইয়াৰ পৰা continuously hollow pipeৰ নিচিনাকে water খিনি ওপৰলৈ গৈ থাকিব. And if the exit gradient I exit, okay, if I exit is less than IC, so the exit gradient critical gradient exit gradient value to যদি বেছি হৈ যায় তেতিয়া কি হ'ব, তেতিয়া basically the gravity dam fails. To overcome that effect we are providing a seed pile. So seed pile কি হ'ব, the water which are followed through these pipes, they now get one obstruction. For that obstruction the length of flow of this pipe increase. Once the length of flow of that pipe increases, that means the gravity beam will overcome that piping failure, right? So to overcome piping failure, the seed piles are provided. So in case of seed pile, the soil which is above the dredge line, that is the ground level, so the soil above the grease line always have active stage. Then below the dredge line always have passive stage. And once at the pivot the soil is active, and at the last point or at the base the soil is passive, right? So passive earth pressure happenings. Here the here the wall moves away from the backfill. Here the walls moves towards the backfill. Here the wall moves away from the backfill. Here the wall moves towards the backfill. Okay, that's why for cohesionless soil, the active pressure and passive pressures, they are here in active, passive, and active passive. This 4 stages is happening in case of cohesionless soil. So we always for analyzing the seed pile wall, we always assume the rotation of seed pile about the base point C. So we are always assuming the rotation of base pile about the base point C. So we assuming the base point C pointer amar basically ki hoy, rotations takes place. So it is the depth of the dredge line, this is the height from the ground level to the top of the seed pile. So the phasor distribution, if you draw by simplify, that is we are assuming the phasor distribution as triangular, and here it is the passive space, here is the active space. Then we'll taking moment about C for determining the embankment depth. For determining the embankment depth, we are taking moment about C. So moment about C কৰিলে আমাৰ কি হ'ব, passive pressure into d by t, because baseৰ পৰা ইয়ালৈকে distance to হ'ব d by t, because it is a triangular distribution. And আৰু আহিব activeৰ পৰা passive, this is a PA, so PA is plus d by t, but direction is opposite, right? So now substitute the value of PP value to is a half of Kp gamma d square into d by t minus half of K gamma h plus d square h plus d by 3. From here I know the value of h from the soil parameter. I can determine K1, gamma I know, Kp I know, the only unknown is d, so we can solve for d. Okay, and in the sum of the case we will also consider the factor of safety, and the factor of safety is basically the resisting force divided by rotating force. Resisting force is PP into d by t, that is passive earth pressure, this is resisting, and rotating force is basically PA into h by d plus 3, right? So from there we can determine the factor of safety. So that's all about the seat pile wall. There are several problems regarding seat pile wall. Try to solve all that seat pile walls numericals. Some numericals, any competitive exams, some numericals are coming from seat pile walls. So try to solve that uh, seat pile walls. And now we'll move to the retaining walls. Okay, so we'll go for the retaining wall now. So retaining walls আমি এতিয়া discuss কৰিম. So we'll go for retaining wall. So in retaining wall, we are basically discussing about in designing of retaining walls, the seat piles walls and other retaining structure pressure exerted by materials retained by this structure is also considered. This pressure exerted by retained material. The pressure which is exerted by the retained material is known as uh, retained material is known as earth pressure. As soil mass, retaining material retained by the earth retaining structure is termed as backfill, which may have top surface, horizontal or inclined. This is the backfill, this is the retaining wall, and this is the surcharge. Surcharge means the extra load, and this extra load sometimes it will make angle with some angles with horizontal, and this angle is known as beta. Okay, so we have we are studying the artificer at active stage and artificer at passive stage. One more pressure is there, that is artificer at rest condition. So sometimes the wall doesn't move, but still there is a pressure exerted, and that pressure is artificer at rest. If the wall is rigid and unyielding, soil retained its by it is in the state of rest and there is no displacement. No displacement means the soil doesn't the wall doesn't move away from the backfill, or the wall doesn't move towards the backfill. It will remain stationary. The pressure exerted by the soil on the wall in this stage is termed as earth pressure at rest conditions. So we have to know how to determine the stress at rest conditions. Suppose this is the wall or retaining wall. Suppose the height of the retaining wall is H, and suppose we are taking one small soil particles, and suppose the thickness of that soil particle is dz, or the height of that soil particle is dz, and the distance from the ground level to that particular soil element is z. So we are considering just a small elements. And if you see the distribution of vertical earth fissure, obviously the vertical earth fissure will be a triangular in manner, that is linearly increasing, and the value at the base will be k naught sigma z. We have to derive the value of k naught. K naught is nothing but it is the earth fissure at rest condition, the coefficient of earth fissure. Okay, the coefficient of earth fissure at rest conditions. So we are taking one small particle or small elements, that is dz. So in dz several forces are acting. First force is sigma h. Sigma h is basically the horizontal force in that particular elements, and one is sigma vertical, that is the vertical force of that particular soil element. So we are acting sigma s and sigma v. So these forces are acting in that particular elements. So earth fissure coefficient, just like similar to active earth fissure, the ratio between sigma h and sigma v is equal to earth fissure coefficient, that is k. So since we are assuming the particular soil element is elastic, that's why we are saying that the strain value is 0. If the strain value is 0, that means sigma h minus e. If you derive the strain value, then we can get sigma h by e minus mu of sigma h by e minus mu of sigma v by e. That means If we consider the strain in horizontal direction, this is 0 because there is no moment. Soil particle কোনো ধৰণৰ moment নাই because the soil particle is stationary. That's why there is no strain. That means strain in horizontal direction is 0. And from the engineering mechanics, we know the strain value is related to the stress and the elastic modulus of the soil. So from that we can write sigma is by E minus mu sigma is by E minus mu sigma V by E. Okay, so this is the strain in H direction or horizontal direction, and this is the strain in vertical directions. After equating this, we can get as sigma H by sigma V as mu 1 minus mu equal to K naught, right? So where the mu is Poisson ratios, right? So here it took Poisson ratio, right? So Poisson ratio is best. Poisson ratio, or we can get that the rest coefficient of earth feature at rest is related to Poisson ratio, and its value is mu 1 minus mu. So in this lecture we learned that the coefficient of earth feature as active stage as 1 minus sine phi divided by 1 plus sine phi, where phi is the internal angle of friction. We also learned that the active stage force Kp or active stage coefficient is 1 plus sine phi, just reverse of Ka, 1 plus sine phi, 1 minus sine phi, right? So here if you arrange the values, যদি values বিলাক arrange কৰিবলৈ দিয়া হয়, then you can say that the getter value is Kp, and after that K naught is coming, and after that Ka সবতকে ডাঙৰ হৈছে আপোনাৰ Kp, then the intermediate value is K naught, and the small value is active, that is Ka. So the active earth feature Ka is small, then in intermediate stage the active pressure at rest, and the larger pressure is basically the larger coefficient is basically the passive earth feature coefficient. So we basically determine the value of K naught, Kp, and Ka in this lecture. Then we'll move to the next part. So here we can determine the vertical stage or horizontal stage. So horizontal stage is basically the base. In the base we can write as K naught sigma V, and sigma V is nothing but gamma into H. Gamma is nothing but unit weight of the soil, and H is the height. Okay, so if you consider the stress at a depth Z, so we can write as P naught is K naught gamma Z, right? So here at a depth H, K naught gamma is, and at a depth Z, K naught gamma Z. So we can say that the distribution is linear, since the Z is this will always have power 1. That's why we can say it is a linear distribution. Jodi amar yate 2 thakile, and then we can say that this is a square or parabolic distribution, we can say. But here since it is an only one term Z or H, that's why it is a linear distributions. Okay, so the pressure at, if you consider the top point of the wall, see the figure. If you consider the top point of the wall, since the here the Z value is 0, that's why K naught gamma into 0, the value is 0. Here Z value is H, that's why K naught gamma into H. So then the distribution is linear, and this earth feature at the resultant earth feature is always acting H by T, because since it is a triangular distribution from that base, the distance is H by 3. So H by 3 into P naught is the resultant moment, you can say. So next we'll move to the some derivations of total earth feature force, earth feature thrust on the wall. So how to determine the earth feature thrust on the wall? So we can determine the earth feature thrust using 3 ways. First way, using integrations. Secondly, we can measure earth feature using the average earth feature concept, and general general concepts. Okay, so we'll try to discuss all this now. Okay, we'll try to discuss all this now. So here, see, here you can see that, here you can see that P naught is basically integrations of P naught dA. dA is the area and P naught is the pressure. Pressure into area is basically given the force. So we are try to determine the force, right? So 0 to A is K naught gamma Z into dz into 1. So আমি soil element এটা লৈছিলো, soil elementor active earth pressure at that point Z we are getting K naught gamma Z, right? So at the point Z we are getting K naught gamma Z. Okay, ইয়াতে figured আপুনি চাব পাৰে, and that is K naught gamma Z. This value is P naught, right? So at the Z point, the P naught value is K naught gamma Z. So we are putting that value. And the area is basically, if you assume the 1 per meter run, dz into 1, right? So from there, we can determine the active pressure, or we can determine the earth pressure at the rest, or earth pressure thrust. P naught is nothing but half of integration of Z is basically Z square by 2, and Z square by 2, since the limit is A, we can write it A square by 2, since the limit is 0 to A. So we can get the final value P naught is equal to half of K naught gamma H square kilonewton per meter. Why kilonewton per meter? We are assuming that the angle, we are assuming the height is per meter length. So this is basically length, and this length we are assuming as 1 meter. So here karone ami unit লিখছো kilonewton per meter. Although it is a force, since ami per meter determine কৰি আছো, here karone ami yak basically kilonewton per meter বুলি লিখিছো, right? Next we'll move to the next part. That is next procedure, how to determine the active earth pressure thrust, how to determine the rest earth pressure thrust, not active earth pressure thrust, rest earth pressure thrust. For determining the rest earth pressure thrust, we can go for the we can carry out the average earth pressure. Average earth pressure মানে আমার যেটো distribution আছিলে, at the top it is 0, at the bottom আমি find কৰিলো K naught gamma A. So we'll taking the average of that stress, and since the length is height is h, and height of that pressure diagram is h, and we are considering 1 meter length, so h into n it will consider as an area, right? So we'll consider h into n1 as an areas, right? So for that we can say that P naught is nothing but half into K naught gamma h square, right? This is the force. Similarly, in the general figure, in the general we will use third approach for calculations. P naught is equal to area of the pressure distribution diagram into 1. So generally আমি কি করো, area to লৈ লওঁ. This is the simpler method. Area to কিমান হ'ব, এফালে আছে K naught gamma h. Area is obviously the area of the pressure diagram always give the force. That is the principle, right? So if you consider that area, so half into base is K naught gamma h into height is h. So we'll get the earth pressure at rest as a half of K naught gamma h square, right? Then we'll go for the line of actions. So at what point that resultant thrusts act? Now our purpose is to find the points where the resultant forces act. So that is basically the line of actions, right? So now our job is to find where the P naught will lies. So P naught will act at Z equal to h by t from base. So for pure sand, K naught is nothing but 1 minus sine phi. Okay. So this formula you have also remember it. And since it is a triangular distribution, the force is obviously act at a distance h by 3, right? So that is the midpoint, or that is the point. Okay. This distance is h by t, and যদি আমি আপওয়ার্ডৰ পৰা যাওঁ 2/3 of h. Okay. So সেইখিনি আপোনালোকে moment of inertia যেতিয়া ক্যালকুলেশন কৰিছিল সেই সময়ত ষ্টাডি কৰি আহিছে, and the pressure distribution from the pressure distribution diagram, if you can calculate the thrust, and the line of action will be obviously h/t distance from the base. And for pure sand, we can use artificial coefficient formula as k naught is equal to, যদি আমাক pure sand দি দিয়ে তেতিয়াহ'লে artificial coefficient formula will be 1 minus sin phi. And if it is given as over consolidated soil, over consolidated soil মানে those soil where the in the history, গোটেই হিষ্ট্ৰীত ইন দ্য হিষ্ট্ৰীত যদি তাৰ ইফেক্টিভ ষ্ট্ৰেছটো আগতে সি বেছি এক্সপিৰিয়েঞ্চ কৰি আছে, নাও ছাপ'জ সি এক্সপিৰিয়েঞ্চ কৰিছে 30 কিলোনিউটন, আগত যদি সি এক্সপিৰিয়েঞ্চ কৰিছিলে 1000 কিলোনিউটন পাৰ মিটাৰ স্কোৱাৰ, দেন ডেট পাৰ্টিকুলাৰ ছইল ইজ নোন এজ অভাৰ কনচলিডেটেড ছইল। এণ্ড তেনেকুৱা ধৰণৰ ছইলৰ ক্ষেত্ৰত কে নট ইজ ইকুৱেল টু কে নট এন চি অফ দ্য ছইল। আমি নৰ্মেলি কনচলিডেটেড ছইলৰ কে নটটো উলিয়াই ল'ম, তাৰ লগত অভাৰ কনচলিডেশ্যন ৰেচিঅ' ৰুট অভাৰ লৈ ল'ম। অ'কে, we'll take the ratio of over consolidated soil. Okay, then we'll go for the different shape of footing. যদি আমাৰ ফুটিংছ বিলাকত আমি কেনেকৈ বিয়াৰিং কেপাচিটি ফাইন কৰোঁ সেইখিনি আমি এতিয়া ডিছকাছ কৰিম। হাউ টু ফাইণ্ড দ্য বিয়াৰিং কেপাচিটি ফৰ ফুটিংছ। অ'কে, চ' ফৰ ষ্ট্ৰিপ ফুটিং চি এন চি কিউ এন কিউ 0.5 বি গামা এন গামা। Try to remember this formula. Here C and C is the cohesion, and C is the bearing capacity factor, Q is basically the effective stress or the surcharge, and NQ is basically the bearing capacity factor 0.5. Beta gamma is unit weight, beta is the width of the foundation, and N gamma is bearing capacity factor. Okay, so similarly we have square footing. In case of square footing, the value is 1.3 CNC. The modification is coming this. We are adding 1.3 CNC Q and Q, and this value will decreasing as 0.4 B gamma N gamma. Okay, so try to remember the formulas. For steep footings, the bearing capacity we can write as CNC Q and Q plus 0.5 B gamma N gamma. And for square footing, we can write as 1.3 CNC plus Q and Q plus 0.4 B gamma N gamma. And for circular footing, we can write as 1.3 CNC Q and Q 0.3 B gamma N gamma. And for rough foundation, we can write as bearing capacity factor as 1 plus 0.3 B by L CNC Q and Q 1 minus 0.3 B by L half of B gamma N gamma. These formulas are important while we're considering the measuring the bearing capacities, right? So for bearing capacities, in MCQ question, they may ask whether for steep footing the cohesion is linearly dependent or square or root over, how the cohesion value is determined. That type of questions may ask in MCQ exam. Okay, so we have another modification for shear failure. Sometimes the values can be mobilized for shear failures. We are not directly taking the value of phi. Sometimes we mobilize the phi value as phi m. Okay, so in the above equation, generally shear failure is considered, but soil may fail into local shear. So to consider the local shear effect, we may consider the modified shear parameters, not the exact soil parameter. We are considering as cohesion value as a cm. We are considering the internal angle of friction as a phi. Okay, to teneke ami determine koribo paru. Modified friction angle phi m will be used for the determinations of nc, nq, and n gamma. So cm is 2/3 of c. Okay, the formula how to convert the cohesion value into to take account for local shear failure, we are just converting the cohesion value as cm. So amar jot cohesion c value asile, c value to ami transfer korilam, mobilize korilam 2/3 kori pele. Tenedore jot angle phi asile hetu ami modify korilam 10 phi m is equal to 2/3 of 10 phi, right? So phi m is nothing but 10 inverse of 2/3 of 10 phi, right? Then we have also have to have conceptually we can also see the effect of water table. Jodi amar water table ahi jay, then what will be the sense of the factors, the df values, or what is the sense of beta values? This also you have to understand. Okay, when the water table in zone 1 depth z1 levels as the z1 is greater than b, this part will be discussed in the next class. That is the last part of that artificer chapter. And after that, this bearing capacities theory will go for the Scampton parameter theory. This is also important. This is how to determine the net ultimate bearing capacity. What is the difference between net ultimate bearing capacity and ultimate bearing capacity? Then we'll go for the Meyerhof equations. Then how the ultimate bearing capacity is given using Meyerhof equations. What is the advantage of Meyerhof equations? Then we'll also go for the IS code methods. Then another important topics for geotechnical engineering, in case this is plate load test, how the plate load tests are determined. Then we'll also determine about what is the elastic settlement and contact faces. This will also will discuss. Then we'll also go for the rectangular footings design. Then next we'll also move the next we'll try to solve some numericals so that the concept will clear. So সেইখিনি আছিলে artificial theory. So সেইখিনি আমি discuss কৰিম in the subsequent lectures. যদি আপোনালোকে মোৰ চেনেলটোত নতুনকৈ আহিছে দেন চেনেলটো লাইক শ্বেয়াৰ এণ্ড ছাবস্ক্ৰাইব কৰিব। Meyerhof, then nutritions, then elastic pavement, then rigid footing, flexible footing, difference between the elastic settlement and contact faces. Hey term can you discuss for him? So we'll do some live class in the next day also. So যদি আপোনালোকে ভিডিওটো চাই ভাল পায় দেন লাইক কৰি দিব। So mainly আজিৰ ভিডিওত আমি কি কি শিকিলো will quickly give one overview. That is we'll learn about the active art pressure. So active art pressure is the pressure when the wall moves away from the backfill. Okay, and secondly we'll discuss about the passive art pressure. So passive art pressure, in this case the wall moves towards the backfill. That is the important. Then we try to derive the we also know that the failure weights 45 degree minus 5/2 in case of passive. And then also we learn about in case of active the failure weight is 45 degree plus 5/2, that is opposite. Then we also derive the equation for the cohesionless soil. For the cohesionless soil we get the Ka value as, that is coefficient of active art pressure, 1 minus sin phi divided by 1 plus sin phi. And similarly active art pressure we get Pa is equal to Ka into sigma v. Then we also derive the equations for cohesionless soil in case of passive stage. And in passive stage we got the value as 1 plus sin phi, 1 minus sin phi. And we also establish the relationship between Ka into Kp is equal to 1. Okay, then we also see the distributions of art pressure in case of active and passive art pressure. Then we also derive the relationship between the active art pressure and passive art pressures for the cohesion, for the cohesive soil like clay karone kenuka dhorono hoy. And we finally arise the sigma s is Ka sigma v minus 2c root k for passive art pressure. And for active art pressure the Pa value or the sigma s value is Kp sigma v plus 2c root over Kp. Okay, সেইটো আমি arrive কৰিলো। সেই দুটা formula we are deriving. And we also discuss about the tension crack, and also we are discuss about the lateral support কি হয়, tension crack কি হয়, সিহঁতৰ formulas বিলাক আমি discuss কৰিলো। Next we also discuss about the seat pile wall code provide কৰা হয় basically the gravity dam for ক্ষেত্ৰত seat pile wall in the below the gravity dam we are providing the seat pile wall to increase the flow path so that the gravity dam becomes stable or it resists the piping failure. Okay, সেইকাৰণে আমি discuss কৰো। Then we also discuss about the drift line or the design of seat pile, how the seat piles are designed. Seat pile designer ক্ষেত্ৰত আমি basically the minimum depth of the embankment আমি calculate কৰিছিলো। Then we also determine the factor of safety. So after determining the factor of safety we are determining the D safe. Then after that we also discuss about the values of We also discuss about the ultimate bearing resistance. So some formulas we are discussing, that is uh, then also we are also discussing about the retaining earth wall, or we can also determine the shear the earth pressure at rest condition. Rest conditioner ক্ষেত্ৰত আমি ফৰ্মুলা এটা ডিৰাইভ কৰিছিলো μ1 - μ। তাৰপিছতে আমি চাইছিলো অভাৰ কনসলিডেট কেছত কি হয়, দেন কনসলিডেট কেছত কি হয়, দেন দা ৰেষ্ট প্ৰেছাৰত পি নটৰ ভেলুটো কিমান হয়, দেট ইজ হাফ কে নট গামা এছ স্কোৱাৰ, দেন কোনটো পইণ্টত এক কৰে h/t পিউৰ চেন হ'লে দ্য ভেলু ইজ 1 - sin phi, and the over consolidated soil হ'লে the value is basically the k naught nc into root over OCRs. Then also we are give some modifications like strip footing or ক্ষেত্ৰত bearing capacity কিমান হয়, square footing or ক্ষেত্ৰত কিমান হয়, circular footing or ক্ষেত্ৰত কিমান হয়, then rectangular footing or ক্ষেত্ৰত কিমান হয়, সেইখিনি আমি ডিসকাস কৰিলো। Then we are also discuss about the modifications of the shear failure. So shear failure modification কেনেকুৱা হয়, and the water table corrections modifications will be discussed in the next class. So thank you for watching. So যদি আপোনালোকে ভিডিওটো চাই উপকৃত হৈছে বুলি ভাবে, then like, share and subscribe কৰি দিব চেনেলটো। Thank you for watching.